You are watching live coverage of the maiden flight of Galactic Space's newest and most powerful launch vehicle. My name is Quingo. I am part of the media team here for GSST, and I will be your host for today's launch. Standing tall at Launch Complex 2 at the Rodriguez Key, Florida launch site, Theia is preparing to lift off on its debut mission to low Earth orbit, carrying a batch of 8 experimental satellites for the GalacticNet program. Theia is a two-stage launch vehicle standing 85.3 meters tall with a core diameter of 5.4 meters. Fully fueled, the vehicle weighs over 1,200 metric tons at liftoff. And at T0, 25 PS4B engines at the base of the first stage will ignite, generating 14,700 kilonewtons, or roughly 3.3 million pounds of thrust. That is enough to push the vehicle through the Earth's atmosphere and into space. The engine layout includes a single center engine surrounded by an inner ring of 8 gimbaling engines and an outer ring of 16 non-gimbaling engines. That gives us system redundancy and precision control throughout ascent and landing. This will also be GSST's first attempt to propulsively land a booster. After stage separation, the first stage booster will execute a partial boost back burn and reorient itself for re-entry, and then it will attempt a controlled splashdown off the coast. That system has heritage from our Rhea booster splashdowns, but this is the first time we'll test it on Theia and hopefully get a somewhat survivable rocket stage after that. Currently 30 minutes from launch. Fueling has been underway for around almost an hour. The tanks are almost fully topped off with their RP1 or RP1 and liquid oxygen fuels. RP1 is what powers this launch vehicle. It is highly refined kerosene, rocket propellant 1. It is a relatively easy and efficient rocket propellant. On the second stage, Theia uses 2 brand new vacuum-optimized BS2C engines, also built by GTRAD. Those engines will ignite following stage separation and carry the payload to orbit. So right now, about T-minus 12 minutes, 15 seconds, the flight computer is conducting final polling across vehicle avionics. The guidance, navigation, and control systems are configured and standing by. Environmental conditions are with limits. We are around a 95% on weather today. Upper level wind data is favorable and the range is currently green. No aircraft or marine traffic is violating any exclusion zones. Again, payload on board today's flight, group of 8 GalacticNet experimental satellites. Those are intended to validate the system and constellation coordination. If successful, this deployment will mark the first orbital segment of what could become a larger mesh network for data relay. Theia has been in the works for a few months now, having conducted a first stage static fire back in May. And I would also take this time to say happy birthday to this group. It has been just over a day over 1 year since this group split off from its parent group. We have achieved a lot in this short 12 months, and we expect to achieve a lot more in the upcoming months and maybe years. Right now, engine chill is starting on the first stage, so supercooled liquid oxygen is being cycled through the turbo pumps of the first stage engines to condition them for ignition. That prevents thermal shock to engine hardware during the high pressure and high temperature startups at T0. And you can also see that cloud around the vehicle, those clouds around the vehicle, that is the result of vapor on the outside of the tanks and cryogenic boil off being purged from inside the tanks. That cryogenic fluid turns into gas upon reaching the ambient air temperatures. The main objective of this launch today is to reach second engine cutoff, and that will put us in a stable orbit. And then the experimental objective for this mission starts after the booster separates. It will attempt to perform an offshore landing.
Hey, Joe.
With a partial boost back burn, as I mentioned previously. We would like to take a moment right here. GSST, we'd like to thank everyone who has supported us over the past year. Support is what makes everything possible, and we are very thankful to all the people who have stuck with us, and we can't wait to see what we can do next. Coming up on 5 minutes, we will have the test of the first stage aerodynamic grid fins. Those grid fins help steer the vehicle down through the atmosphere as it's coming back for landing. paired with the 9 inner engines with their thrust vector control. That whole system guides the booster back for its landing, whether it will be on drone ships or landing platforms, or in the ocean, like today. There you just saw the test of the aerodynamic grid fins. As I said before, those titanium grid fins help steer the vehicle as it's descending through the atmosphere. So that test verifies that they are working as they should, and by the looks of it, it seems that that was successful. So we are coming up on the final countdown. Teams are conducting final go, no go polls across the board. All stations are currently, at this moment, reporting green. Vehicle health is as expected. So right now the external power from the vehicle has been disconnected. It is now operating on its internal batteries. So any hold will require a recharging of those batteries. Propellant loading is expected to wrap up in about 50 seconds at 1 minute 20 seconds. Should hear that call out. Tank pressurization is on their way. As the fuel loading completes, it is bringing up to, all tanks are being brought up to flight pressure. Engine valves are in their start modes. The flight software is fully configured and verified. Flight termination system arming coming up soon. The flight termination system is a safety protocol designed to safely terminate the rocket if it veers off its flight corridor. Both primary and backup pyrotechnic chains. There you hear that call out for prop loading completion.
Ground gas closeouts.
Ground gas closeouts. That means that all propellant lines are now being purged. The vehicle and ground support equipment is transitioning towards launch configuration. There we pass 1 minute. Theia is now entering into startup. The ground launch sequencer is has handed over control to the vehicle's autonomous launch sequencer. It is now in control of final countdown events. It will be monitoring the vehicle and vehicle health up until T-minus 1 second.
LD is go for launch.
Then we got the final go for launch received from the launch reactor. Range remains green. Vehicle is confirming power stability. Ignition start command is locked and pending at T-minus 10. T-minus 15. Launch teams can no longer recycle the countdown.
10,
I'll hand off
9,
to cruise control.
8, 7, 6, 5, 4, 3, 2, 0. Ignition. Max Q. Vehicle's
Vehicle
lost.
Theia is now supersonic, past the speed of sound. It has passed through its maximum dynamic pressure, or max Q.
Stage 2 engine chill.
As you saw and as you heard, Theia lifted off from Launch Complex 2 just 2 minutes ago. We're currently coming up on shutdown of the first stage, and then you'll have separation of the first and second stage, and start of the second second stage engines. And then we will hopefully see the experimental boost back burn of the first stage.
Miko. Stage separation. Stage separation confirmed. BS28 ignition.
You just saw separation of the first and second stage, and the boost back startup for the first stage. 8 engines performing nominally.
Stage 1 heading back to landing zone.
That's a good call out. The first stage performing its partial boost back burn to guide it to a landing off the coast. There you saw separation of the payload fairing.
Stage 2, power and telemetry nominal.
That payload fairing protects the vehicle and payload during launch, improving aerodynamics. Once we exit the atmosphere, that is not needed, so we jettison it. First stage continuing its boost back burn. 7 engines. There you saw shutdown.
Stage 1 shutdown.
Second stage still performing, 2 engines burning, carrying that vehicle and payload to orbit. First stage shut down its engines, now reorienting itself for entry into the Earth's atmosphere. Those grid fins deploying.
Stage 2 trajectory nominal. We have lost communication with the first stage booster.
Teams in mission control lost communication and telemetry from the first stage booster. That is okay. That was the experimental portion of our flight. We weren't expecting perfection. This is an experimental test flight, so that is okay. But second stage still performing, both engines burning, carrying the rocket and payload to orbit. Soon, in about 20 seconds, you'll hear the call out for terminal guidance. That is where the vehicle will transition into its final phase of flight. It will be navigating and targeting itself to the final target orbit in space. stream diagram showing one engine out in the second stage, though it does appear that we have both engines burning. We are continuing to see good performance of the second stage. Rhea liftoff successfully 12 minutes ago. It did appear that we had a loss of the first stage booster, but that was not entirely unexpected. But currently, the second stage is continuing to burn, both engines up and running. Even though the engine diagram shows one out, the cameras show that both engines are performing. So probably just a UI issue. Continuing that second stage burn to carry the payloads and the vehicle to its target orbit.
BS2A shutdown.
There you saw a shutdown of the second stage engines.
Stage 2, FTS saved.
There we had stage 2 FTS saves. That vehicle, the Theia vehicle, now in its stable target orbit, essentially completing our mission today. We achieved all the main major milestones for the launch today. Very impressive stuff.
Wait, what happened?
I gotta get my little. Wait, let me get my little outro thing. So, 17 minutes ago, 17 minutes, 40 seconds ago, we had successful liftoff of the Theia launch vehicle. That first stage performed normally despite multiple engine shutdowns. That was not entirely unexpected. We had successful stage separation and second stage ignition. The boost back burn of that first stage did start up successfully. First 8 and then 7 engines successfully powered the vehicle on its trajectory for its attempted splashdown. It did appear that during entry of the first stage that there was a loss of telemetry, so we will have to look into that possible breakup of the first stage. But we did lose that first stage. It was not. It was a experimental portion of the flight, so we did not expect it to go perfectly as planned. Improvements will be made, but success comes from what we learn, and we did have a major success as we reached SECO and we are in our target orbit. Despite minor issues, we will. This is a test flight, of course, the first test flight. So we will continue to improve our system and improve reliability. But since our mission has wrapped up today, I will wrap up my commentary. So yeah, that is all I had to say. Thank you for tuning in. Thank you for watching. Thank you for supporting. And we will see you back here for the next launch. I have been Quingo, and I will see you next time.